Okay, greetings everybody. In this lesson, I'm going to show you how to draw a trochoid. This one is specifically an inferior trochoid. And it is going to roll for one revolution. And this is the point P that we're plotting. And remember, an inferior trochoid is a cycloid where the point P is within the circle being rolled. You have also a superior trochoid, and that superior trochoid, the point would be outside, right, as the circle rolls. Remember that the regular cycloid, the point would be on somewhere on the circumference, whether here, it can be at any other point. So for this example, I'm going to demonstrate the simplest way or the simplest form of the superior trochoid, where the point is directly below the center of the circle, that is the rolling circle. Now the first thing that I'm going to do is I'm going to draw the circumference of the circle. Let me delete this line. I'm going to redraw it as a circumference. I've already worked out the circumference. By the way, the circle diameter is 70. So when I work out the circumference of that circle, that is pi times diameter, I end up with a measurement of 220. So 220 is the circumference of this circle. Right? Let me just work that out. Let me just double check that. Yes, the answer is 220. So that's the first thing that I'll do. The second thing that I'll do is this. I'm going to divide this line in 12 equal parts. Now it's up to you how you divide it. You can use path array. I'm going to use path array. You have to select the path curve or the distance. In this case, you select the line and then press enter. So by the way, let me just do this first. Let me, before I even divide the line in 12 equal parts using the array, I'm going to need to draw a line, the line that is going to be divided in 12, or divide the line in 12. So let me go back to path array to select the let me select the object so I want to array, and then press enter, then select path curve. Now I need to select the items. So I type items and press enter. Then I select the distance between EX. I'm typing 13. The reason why I'm typing 13 is due to the fact that you need 13 lines to divide the object in 12. Let me count the amount of lines that are here. 1, 2, 3, 4, 5, 6, 7, 8. I may be doing something wrong. Let's try this again. So I'm selecting path array and select the object, then enter, and path. After I've done that, I need to select the method. The I'm typing method, then enter. After the method, you're going to type divide, D, enter. Then after divide, you're going to type items. So that's how I should have done it. Then I'm going to type 13. Now the line is divided into 12, but with 13 items. So if you're going to divide a straight line into 12, you're going to need 11 items plus the 2 on the end. That makes up the 13. Then you press enter. Alright, so now that this line is divided in 12, the circle will roll on this line, and when P returns to its position over here, then you have 12 divisions, or the one revolution. The next thing that I'll do is to draw another circle that is going through the center of the point. And then that circle, you're going to divide it in 12. So this is what I'm going to do. I'm going to draw another line through the circle. This time I'll make it horizontal, passing through the center. Then I'm going to use array again. You can use any method of your choice to divide this in 12. I'm going to use the polar array. Select the object. Then press the center. Then I'm going to type items. And in this case, once you're dividing a circle in 12 equal parts, you are going to use 12. Alright. And that's it. The circle has been divided. So for both arrays, I am going to explode them so that they become individual lines. Now these points on the circle, I am going to bring them across. All the points that are formed on the circle are going to be brought across. Let me just trim off these, and I'll just mirror these. Alright. So remember, this is the rolling circle. Let me change the colors. Something is amiss here. Let me redo this. Alright, so let me change the colors. Alright, so the white circle is the rolling circle. Point P is in the circle. Point P is in the circle, not on the circumference. Okay, so you have a point here. This is point 1. I'm not getting this right at all. I want to copy this point, or the labeling rather, so that I can label this point 1. Alright, and this point is 1 here. So this is what I am going to do. I'm going to create another circle. Let me use a different color so that you don't mix it up with the original circle. I'm going to do the same thing. I'm going to copy all of the circles and all the points. All the center points. So the points that I'm using, at different points, the center of the circle will be at these points. So that's why I'm copying these circles. Now it's similar to the regular cycloid, but the only difference is you're drawing a smaller circle within the larger rolling circle. And you're basically calculating the different points. So the first point that would be here. This point of intersection. So this is the first circle, and it is cutting the first line. And then the second circle, second line, third circle, third line, fourth circle, fourth line, the fifth circle, fifth line, and of course the sixth circle, which is this one, will be on the top. Now all you need to do is to copy these points and mirror these points, this where the top point is, and then you are now able to plot the cycloid, or the superior, the inferior trochoid rather. I think this point, something is amiss here. Realize that one of the circles were not placed properly. I'm going to fix it afterwards. So this is the cycloid. Thinking this circle, to realize it's not on the center. So when I bring it over the center, now you realize that it's in line with the intersection. I think this one, I did not put this circle correctly. It should have been here. So that was the few minor mistakes. And this is the trochoid. This is the trochoid, the inferior trochoid. When the point is inside the circle, remember this is the rolling circle, not the blue circle. The white circle is rolling along the white line, and the point that is inside the white circle, the path of that point, which is referred to as a trochoid, in this case an inferior trochoid because the point is inside, that part of that point is being plotted. So there you have it, an inferior trochoid of a point P as the circle that is associated with rolls along for 1 revolution. Alright, so that's it, everybody. Have a good day.